Good morning, everybody. Time about triangles with your favorite YouTube star. I think I have like 8 followers now, so I know. All right, so just finished talking about similarity in triangles, and we know that when you have two triangles that are similar, they have that kind of scale factor to them. So this is similar to that. We're still going to be using ratios and still going to be using proportions. Just in a little bit of a different way. So this is called the triangle proportionality theorem. So proportionality is a pretty huge word, but what it means is that in a triangle, there are proportions. And this is a very specific situation where there's proportions. So the first thing that happens with the triangle proportionality theorem is that we know the only time this theorem kind of comes into effect for us is when you have a triangle and you come into the middle of the triangle somewhere in the interior of the triangle, and you draw a line that connects two sides that happens to be parallel to the other side. So if you look down here in this diagram that I have, we have this triangle RTS, and then this little segment on the inside, XY. Notice it connects on this side, on side RT, and it also connects on this side TS. And if we're going to use proportions here, what we need to know is that this line right here and this third side are parallel. If we know that those are parallel, then we know that there are certain proportions created in this triangle. Okay. The proportion is this. If you draw a line, doesn't matter where you draw this line, if you draw it parallel to a third side, then what we know is that these two chunks over here, so this side gets cut into chunk number 1 and chunk number 2. Right? There's a proportion here that matches the same thing that happens on the other side. So we'll be able to set up proportions and figure out side lengths. So in other words, anytime you draw one of these parallel lines through a triangle, I get two ratios and they have to match, right? The ratio of 1 to 2 over here and the ratio of 1 to 2 over here have to match. Okay, so in this example, notice I have my triangle ABC, and here comes this line DE through the middle. Now, the only reason I'm able to set up the proportions I'm about to set up is because of these little symbols right here. Remember, those little symbols mean parallel. If I don't have parallel, I can't do this. So if these are parallel, here's what I know. I can set up a ratio to this side length, BD, to the other chunk, DA. And I know that it has to match the ratios on the other side. So BE to EC. And then this is going to look a heck of a lot like the similarity problems that we did in the last section, right? So you're going to be given some numbers, maybe an expression in terms of X, I don't know. And then we'll just do a cross multiply and we'll solve it out. Now again, when it's numbers, some of you are able to look at it and just go, oh, that's double or that's triple. And if you can figure out the numbers without setting up a proportion, good for you. But you can always set up and solve a proportion with cross multiplying. It will do it for you every time. All right, let's look at an example. Okay, so the first thing I want to do in any one of these problems is look for these symbols. Now these arrows are colored in, whatever, it still means parallel. So I know these two lines are parallel. So I'm not so much concerned with this line. I'm concerned with what it does to the other two sides. Now notice over here, I have a 2 for a short piece and a 6 for a long piece. So there's my first ratio, 2 over 6. On the other side, I have X for a short piece and 9 for a long piece. So I have an X over 9. And I know those two things have to be equal. Now, some people might say, oh, look, 6 to 2, that's just divided by 3, right? So I could come down here and say 9 divided by 3. I think this is going to be a 3. But if you don't notice that, you don't see that, I probably wouldn't have. You just set up your little proportion and we'll do our cross multiply. So let me grab another color here because me. All right, let's do our cross multiply. 2 times 9. And on the other side, 6 times x. And we have a nice little one-step equation here. This is 18 equals 6x. So we divide both sides by 6. And we get x equals 3. Again, that's what we thought. Right? Look, 2 times 3 is 6. 3 times 3 is 9. We have our proportion. Again, the only reason I'm able to set up that proportion is because of these parallel lines. If those parallel lines aren't there, they can look parallel all day long, but if they're not marked parallel or we're not told they're parallel, we can't do it. All right, here's another one. You know I love this one because look who showed up. Ooh, yeah, an expression in terms of x. That's no algebra. Okay, first things first. Do you have parallel lines in here? I have a triangle, and I got this guy coming through the middle, and boom, boom, they're parallel. So I know I can set up 2 ratios, and I know they're going to be equal. So let's do the number side first. I got this little piece right here, which we know is 8. The question is, how big is this big piece? We have to be really careful with this one. They thought they were cute, and instead of giving me the length of just this piece, they gave us this whole side length. But that's okay, because they told us how long this piece is. So this piece up here isn't 28, Isla. Please don't do that. It's not 28, it's 28, take out this 8. So this piece up here has to be 20. So my first ratio for that side is going to be 20 and 8. 20 for the big piece, 8 for the small piece. All right, so on the other side, I have big piece, 3x minus 5, and I have a small piece of 10. Okay. Now there's no reason that you have to do big to small. You could do small to big or whichever one makes you happy, but just make sure that if you do big to small on one side and you do big to small on the other, you don't want to switch it up, right? You wouldn't want to do big to small over here and then over here do small to big. You'll get a wrong answer. All right, so once my ratio is set up, let's do our cross multiply. 20 times 10 is 200. And on the other side, I have 8 times this whole expression. So please remember, if you have a situation like that, you've got to put that expression in parentheses and do a distribution. So I'm going to do my rainbow. So 8 times 3x is 24x, and 8 times 5 is 40. I'm going to keep my minus. Let's see, add 40 to both sides. I was hoping I wasn't going to have to go get my calculator. I think I can figure this one out. 240 is 24x, and when we divide both sides by 24, luckily for me, comes out nice and easy to 10. Right? 10 times 24 is 240. So that does not mean that this side length is 10, remember. What that means is x is 10, so that means this side length is 3 times 10 minus 5, so 30 minus 5, also known as 25. It looks like this piece up here is 2.5, so 10, 10, and another half of that. And check it out. 8 and 8 is 16, another half of that is 4, so 16 and 4 is 20. So I know I have the right answer. These long pieces are 2.5 times as long as these short pieces. Okay. So that's triangle proportionality. Now, there's a really special situation with triangle proportionality where we have what's called a mid-segment. And again, this is not a new thing. It's just a very special case of triangle proportionality. Okay, a mid-segment is a special kind of parallel line in a triangle. And you can, if you take a look at this picture down here that's floating over my face, you'll notice maybe what's special about a mid-segment.
I know something.
That you're supposed to be giving me 15 minutes to make a video?
No, I mean a big math problem.
Oh yeah?
100 plus 100 is 200.
It sure is, babe. Thank you. Okay. All right. Fun fact for the day. Okay. So mid-segment, again, parallel to one side, just like the other ones have been so far. The key to a midsegment is that when it cuts the other sides in half, when it hits the other sides and breaks them into two chunks, it happens to be breaking them into two equal parts. It cuts them in half. So I could draw a parallel line anywhere in a triangle, right? Let me find my mouse. Okay, I could come down in here and draw a parallel line here, or I could draw a parallel line down here, and it would still create those proportions we just talked about. If it's a midsegment though, I know for a fact that when it cuts it, this ratio here is going to be a 1-to-1. It's creating two equal parts. So sometimes they'll show you that these two parts are equal and they'll say, and so then we know it's a midsegment. Other times, if they show you that they might give you those numbers and say, and we have to assume it's a midsegment. Or sometimes they'll tell you it's a midsegment and you have to assume those two sides are the same, but we just have to know the definition of a midsegment. Okay, so in English, a midsegment is just a segment that comes through the triangle and hits the middles of two sides. That's where it gets its name. Right? Mid as in middles, segment, it's a segment. It has two endpoints. Okay, so again, what's so darn special about a midsegment? It's really special case of the proportionality thing we talked about in the beginning. It's still parallel to the sides. That's not new. Cuts the other sides into two proportional parts. That's not actually new. What's special about it is that the proportionality is a 1-to-1. Now, what's also cool is that it gives us a new information because it's equal on both sides, because this side got cut into two equal parts and this side got cut into two equal parts. Now I know something about the two parallel sides. And notice in those last couple problems we did, there was no relationship to be talked about between the two parallel sides. So in the triangle proportionality, if you just willy-nilly come in, draw a parallel line through the middle of a triangle, you're going to get the proportions on the two sides. I know absolutely nothing about how the line I drew compares to the line it's parallel to. That changes when we have a midsegment. So here's the deal. It's easy to remember because middle, right? Your midsegment, if you have a midsegment, it's always going to be half as long as that third side, the side that you drew it parallel to. End of story. Okay. So you've got two equal chunks on the two sides that you cut in half. And then this middle piece is always going to be half as long as the side that it was parallel to. All right, so look at this picture. Okay, they didn't say anything about a midsegment, and those lines aren't even marked parallel. But look at the numbers they gave us. I have this triangle and I have this line coming through the middle, right? It's not marked parallel. But look what they gave us. 8 and 8, 9 and 9. I've got 1-to-1, right? So if I wrote my proportions here, 8 over 8 is equal to 1, 9 over 9 is equal to 1. That's definitely equal to each other, right? So I know because of that these lines must be parallel, and I know something else. This line right here has to be a midsegment. Since I know it's a midsegment, I know how long it is because they told me down here that this is 6. So if that's 6, this guy up here has to be exactly half of that, or 3. The key to this problem is noticing you have a midsegment. And again, they didn't mark it parallel. They don't have to because they showed you the side lengths, right? They showed you over here that you have 2 equal parts on this side and you have 2 equal parts on this side. Because they did that, we know it's a midsegment because that's what midsegments do. Right? Even if they had marked that parallel, we wouldn't know it was a midsegment unless they gave us these numbers or some way to know that those numbers are the same. Okay, here's another one. Again, they're not marked parallel. But look at the numbers they gave us. This is 10 and this is 20. If this is half of this, midsegment. So, and again, If I have a midsegment, then I know my midsegment is cutting my sides in half. So if you know your sides are cut in half, then you know you have a midsegment. If you know you have a midsegment, then you know these two things have to be the same. Right? It has to be, this side has to be being cut in half. So if this is 4, then this is 4. And if they told you that this was 10, then we would know this was 10. If they told you that this was 27, we'd know this was 27. 27 seems like too big of a number. Do you think I have one with algebra in it? That's so nice. I'll bet you there's one in your homework though. Okay, so we have session today at 10:45. If you watch this and you have any questions, I will be here. We have session again on Thursday at 10:45. If you have any questions, stop by, and I will be there to answer them. So once you're done watching this fabulous video, head on back to Teams and find your mid-segment and triangle proportionality assignment. Have fun. Happy belated Memorial Day. School's almost over.